Okay, in this section, we're going to talk about infinite limits. These limits actually do not exist. That's how we've talked about them before. So let's take a look at an example here. So here's my function. My function is f of x equals 3 over x minus 2, usually written like this, 3 over x minus 2. And what we want to do is take a look at the limit as x approaches 2, right? So you can approach it from the right, the left, or just say what's the limit as x approaches 2. So far, we've done this. What's the limit of that function as x approaches 2? And we would say does not exist, right? Because we know based on rational functions, there's a vertical asymptote here. Here we've really got the answer. You can see the graph, so the limit definitely does not exist. There is no output there, or there is no y value that the graph approaches as x approaches 2. We could also do from the left and from the right, and this is the new part for us. So we're going to say, okay, as x approaches 2, let's start with the left. It still doesn't exist. If we look at the graph, it doesn't exist. As I come in from the right, this thing is unbounded. It shoots down to negative infinity. Okay, but we're just going to be a little more specific with our does not exist now. Because it's headed in one direction, we can say where it's going. Okay, and that's really all we're doing in this section. So I can say, what's the limit of this function, same function here, 3 over x minus 2, as x approaches positive 2 from the right? Well, if we have a graph, now eventually you're not going to have this chart and you're not going to have the graph and you're going to be asked to figure it out. Okay, so we'll talk about that in a little bit, but with these aids, as I come in from the right, we can clearly see this thing goes up to infinity. Okay, so it's still correct to say does not exist, but what I'm going to expect you to do, if you can tell me basically why it doesn't exist, right? We had a couple cases where limits don't exist. One of them was it was unbounded, and that's really what you're saying here. You're just going to say, well, it goes to infinity. If I come in from the left, it goes to negative infinity. How about this question? What's the limit as x approaches 2? That one still does not exist, right? Because it's different directions from the right and the left, then we can't really be more specific with the does not exist. We just have to say still does not exist. Okay, so let's see. So we already did these. There's your function, but just think about it like this. So let's say we didn't have those aids. How would you do this problem? Let's say you just have this. What's the limit? Well, what I do is, you should know there's a vertical asymptote there. We're going to talk a little bit more about vertical asymptotes because of what you know about rational functions. Okay, so you should know that this is 50-50. It either goes up or it goes down. Which one is it? And what you can do is just say, well, if I approach 2 from the left, that's less than 2. So you can just kind of say, okay, what's less than 2? 1.9 is less than 2, or 1.99. And this actually helps with the whole concept of vertical asymptotes as well. So think about what happens here. You're going 3, and this was in the chart before, but this is how you could do it without doing the whole chart or even graphing it. Just pick a value that's close to 2 coming from the left. And the important part here is that we get a negative small number, minus 0.1. Okay, and that's of course 3 divided by 1/10, so that should be negative 30. And the idea, of course, and I'm just kind of reproducing that chart, if we got a little closer to 2 from the left, then we'd be dividing that constant value 3 by negative 0.01. That's 3 divided by 1/100th is 300, so that'd be negative 300. And really, you don't even need to do all that. You know it's going to either plus or minus infinity. And the important part here is that we've kind of teased out the negative. So we know that that's negative infinity. All right, and we can do the same thing here. So we say 3 over what's just a little bit bigger than 2, 2.01. And then you get a constant divided by an ever decreasing number, a number going to 0. When you divide a positive number by a number going to 0, it goes to positive infinity. Okay, and that's it. That's all we're really doing here. Look at a couple other ones. So if you have a graph, it's real easy, right? What's the limit for this function right here? What's the limit as x approaches 1? Well, this one the limit as x approaches 1 of this function f, new function, is equal to the limit as x approaches 1 from the left, is equal to the limit of the function as x approaches 1 from the right. Right? In this case, because it's squared in the bottom, everything goes up, so they're all infinity. Okay, which wasn't true about, well, it's not true about this one here, right? You could do the right-handed limit. It would go down to negative infinity of this function. You could do the left-handed limit, which would go up to positive infinity. But of course, the limit of the function itself does not exist because they both don't go in the same direction. Okay. So what we do next is, so that's what I'm going to ask you. So could you think about this? Could you do that question without the graph? The limit of, let's talk about this one, negative 1 over x minus 1 as x approaches, and of course I'm going to say 1 and then I'm going to give you one direction. So without the graph, just think about that. In my last example, I talked about that. What I would do is I'd plug in a value that's just to the right of 1. Let's go with 1.1, right? Because that's bigger. I put in 1.1 here. And what do I end up with? Negative 1 over 1.1 minus 1 is 0.1. I don't really care that that's 0.1. I just care that it's a really small value and that it's positive, right? That's the key. And there's a fixed negative value in the numerator. So that ends up going to negative infinity, which we can see, of course, on the graph. Okay. And then the next thing we're going to do in this video is talk about vertical asymptotes, which you already know, right? There's a connection here, right? If your limit goes to infinity as you approach some constant, then that constant, x equals that constant, is an asymptote. Okay.